Yes, good morning to everybody. So yesterday what we learned, what is meant by symmetry. What is meant by symmetry? If a line divides the given figure into two equal half, then it is called as what? Line of symmetry. Now come to the point. So today we are going to discuss about rotational symmetry. What is meant by rotational symmetry? Any object or shape is said to have a rotational symmetry if it looks exactly the same at least once during a complete rotation of 360 degree. That is, you are going to rotate a given figure in either clockwise or anti-clockwise. In one complete rotation, how many times it looks like the same? Am I right? If a figure is rotated around a center point and it still appears exactly as it did before the rotation, that is, how it was looking the same before the rotation, then it is said to have a rotational symmetry. Suppose if you are spinning the wheel of a bicycle, it rotates. Am I right? Yes. Either you can rotate in clockwise or anti-clockwise direction. Now, some examples were given, like a squares, circles, regular hexagon, etc. have a rotational symmetry. Note, a scale and triangle does not have a symmetry if it rotated. How many line of symmetry for a scale and triangle? There is no line of symmetry. So therefore, the scale and triangle is asymmetrical. Am I right? Yes. Now, come to the next point. Center of rotation. What is meant by center of rotation? For a figure or object that has a rotational symmetry, the fixed point around which the rotation occurs is called the center of rotation. Am I right? Yes. Now, look at the example. The center of rotation of a windmill in the center of the windmill from which its blades originate. Or three blades will be there. Am I right? From the center. So, what is the center of rotation? The center of rotation of a windmill in the center of the windmill from which its blades originate. Okay. So, where the three blades originate, it is called as what? Center of rotation. Now, angle of rotational symmetry. For a figure or object that has a rotational symmetry, the angle of turning during rotation is called as what? Angle of rotation. For example, suppose if you are rotating a square, by 90 degree, then it exactly looks like the same. Then again it will looks like a square only. And then after that, again if you are rotating 90 degree, then again it looks like a square. So again if you are rotating 90 degree, that means if you are rotating 90 degree 4 times, it will exactly looks like the same only. So in one complete rotation 360 degree, 4 times it looks like the same. Therefore, what is the central point then? What is the angle of rotational symmetry? 90 degree. It's very simple. How will you find the angle of rotational symmetry? First you find the line of symmetry for that. How many lines of symmetry for a square? 4 lines of symmetry. One complete rotation means 360 degree. So 360 by 4, which is equal to 90 degree. Therefore, the angle of rotational symmetry will be 90 degree. Are you getting it here? Yes. Now, order of rotational symmetry. That order of rotational symmetry is nothing. In one complete rotation, how many times it looks like same? How many times it looks like same? The number of positions in which a figure can be rotated and still appears exactly as it did before the rotation is called order of symmetry. Now, look at the example, you will come to know. That is, one arrow is given. If you are rotating 90 degree one time, it is not looking like the same. Am I right? Yes. Again, if you are rotating 90 degree, that means now you rotated 180 degree. Then up arrow comes down. So then also it does not look like same. Then again rotate 90 degree. That is, now you rotated 270 degree. Then also it does not looks like same. Then again you are going to rotate 90 degree. That means we completed 360 degree now. Now the figure looks like a same. So in one complete rotation, the figure looks like same. How many times? Only one time. Therefore, the order of rotational symmetry will be 1. Are you getting there? Now, then some rotational symmetry for the letters it's given. Just you go through it, you will come to know. Am I right? Now, look at the exercise 14.2. Which of the following figures have rotational symmetry of order more than 1? It may have rotational symmetry or may not have a rotational symmetry. Just you go through once. Look at the first figure, that is circle it is given. Am I right? Now, if you are rotating 90 degree, it looks like same. Again, if you are rotating 90 degree, it looks like same. But here, that is into mark it is given in the center of the circle. That is the important thing. If the center, that is center point is not marked with the asterisk sign, then it may have infinite number of symmetry. Are you getting there? Yes. Shall we move to the next one? Yeah, come to the second point. What it is given? One triangle it is given. It is called what? What kind of triangle is this? Equilateral triangle. What is this? Equilateral triangle. So, how many number of lines of symmetry for that? Equilateral triangle? 3 lines of symmetry. Therefore, what is the number of rotational symmetry? Order of the rotational symmetry is 3. So, it has more than 1 order. Then look at the C part. Look at the C part. Diagram C. Yes. If you are rotating 180 degree. If you are rotating 180 degree. Yes. Then the arrow, that box, right hand side with that box, 2 boxes were given at the end, right? So, it will not looks like a same. Then again, if you are rotating 360 degree, then only it will come to the original position. It looks like the same. So, therefore, the order of rotational symmetry will be 1. Order of rotational symmetry will be 1. Now, come to the D part, H it is given. So, if you are rotating 180 degree, it looks like same. Now, you got 1 order. Then again, if you are rotating 180 degree, that is, you rotate to 360 degree, again it looks like the same. Therefore, the order of rotational symmetry for letter H is 2. Am I right here? Yes. Now look at the E part now. That is, one circle is given. It's divided into how many parts? 3 equal parts. 3 equal parts. Am I right? Now, just to rotate into 120 degree, it looks like same. Again it rotates into 120 degree another time. That means you are going to rotate to 240 degree from the initial. It looks like same. Again, if you are rotating 120 degree, then we will reach 360 degree. We rotated 360 degree. Again, it looks like the same. Are you getting there? So, therefore, the order of the rotational symmetry is 3. Now, look at the F part. It's looking like the windmill. Am I right? Yeah, 4 blades were given. Am I right? Yes. If you are rotating 90 degree, it looks like same. If you are rotating 180 degree, then also it looks like same. If you are rotating 270 degree, then also it looks like same. If you are rotating 360 degree, then also it looks like same. Therefore, the order of the rotational symmetry for the given figure is 4. So, what can we conclude from the given figure? A, B, D, E and F have the rotational symmetry of order more than 1. Of order more than 1. Now, come to the next question here. Give the order of the rotational symmetry of for each figure. For each figure. Now, look at the first question. The diagram is given. If you are rotating to 180 degree, then it looks like same. Again rotates to 180 degree. Again it looks like same. So, when we are rotating to 360 degree, so it looks like same 2 times. Therefore, the order of the rotational symmetry for the given figure is 2. Are you getting there? Yeah. Look at the B part. The given figure has a rotational symmetry as 2. Can you tell me why? Yes. If you are rotating 180 degree, then it looks like same. Again, if you are rotating one more time to 180 degree, then again it looks like same. So, in one complete rotation, it looks like same 2 times. Therefore, the order of the rotational symmetry will be 2. Am I right? Yeah. Come to the third question now. Yes. It is an equilateral triangle. It is an equilateral triangle. So, when we are rotating 120 degree one time, it looks like same. Again rotate to 120 degree, that is 240 degree from the original position, it looks like same. Then again rotate 120 degree to the from 240 degree, then again it looks like same. So in one complete rotation it looks like same. How many times? 3 times. Therefore the order of the rotational symmetry will be 3. Am I right? Yes. Now look at the D part. Here when we are rotating 90 degree, it looks like same. So in one complete rotation, if you are rotating 360 degree, that means the figure looks like same. How many times? 4 times. Therefore the order of the rotational symmetry will be 4. Am I right dear? Yes. Now come to the E part now. If you are rotating 90 degree, it looks like same. Then again rotate to 90 degree, it looks like same. Again rotate to 90 degree, again rotate to 90 degree. So in one complete rotation, it looks like same. How many times? 4 times. Therefore the order of the rotational symmetry is what? 4 for the given figure. Then come to this figure, that is, it is a pentagon, regular pentagon, regular pentagon. So how do you know it is rotated to 72 degree? It's very simple. Regular pentagon, it has how many sides? 5 sides. It has how many sides? 5 sides. Am I right? 360 by 5. What is that? 72 degree. So if you are rotating 72 degree, it looks like same. Am I right dear? Then again rotate to 72 degree. How many times? 5 times. So if you are rotating the given pentagon to 360 degree, at 5 times it looks like same. Therefore the order of the rotational symmetry is 5. The order of the rotational symmetry is what? 5 here. Then look at G now. Yes, it's looking like a star. It has how many tips? 1, 2, 3, 4, 5, 6 tips are there. Am I right? So if you are 6, so how many lines of symmetry it will be? 6 lines of symmetry. Yes. So what is the angle of rotation? 360 by 6, because it has 6 lines of symmetry. So 60 degree. So every time you have to rotate to 60 degree, then it will exactly looks like the same. So in one complete rotation, it looks like same. How many times? 6 times. Therefore the order of the rotational symmetry will be 6. Are you getting here? Yeah. Come to the H question now. Here how many lines of symmetry for this one? Yes, 3 lines of symmetry. So 3 lines of symmetry means what is the angle of rotation then? 360 by 3, which is equal to 120 degree. So you have to rotate 120 degree how many times? 3 times. You have to rotate 120 degree 3 times. So 120 degree, 120 degree and 120 degree. So in one complete rotation, the figure exactly looks like same. Are you getting there? Therefore the order of the rotational symmetry is what? 3 here. Are you getting there? Yes. We will continue in the next video. Thank you everybody. Thank you.